Welcome back, everyone. In this lesson, we are going to concentrate on switched networks. In a switched network design, it follows these basic principles: hierarchical, modularity, resiliency, and flexibility. Hierarchical means they work in a hierarchy and every device has a role in every layer. Modularity allows seamless network expansion and integrated services, meaning that as you grow your network, it becomes easier. Resiliency provides an always available network. You don't want to experience a very long downtime, so your network must be resilient. Flexibility allows intelligent traffic load sharing. Sometimes, as per driving traffic, certain roads are clearer than certain other roads. So certain apps help you go to the less congested road so that the network or the traffic can work better. So this is the flexibility that the network allows as well. So the three tiers, as you know, is the core layers, distribution layer, and access layer. The access layer provides network access to users. Distribution layer interfaces between the access layer and the core layer. And then it provides functions such as aggregating layer 2 broadcast domains and layer 3 routing boundaries. It provides intelligent switching, routing, and network access policy functions to access the rest of the networks. Core layer is the network backbone. It provides fault isolation and high-speed backbone connectivity. In switches, we have the fixed configuration, the stackable configuration, and modular configuration so that you can grow as you need. So when you're selecting switches, these are some of the considerations. Let's look at the switch environment and frame forwarding. There are two terms associated with frames entering or leaving an interface. One is ingress, the other one is egress. Ingress is entering the interface or coming in. Egress is exiting the interface. A switch forwards frame based on the ingress interface and the destination MAC address. So these are the two information it uses before it forwards a frame to the destination. The ingress interface, where it came in, and the destination MAC address, where it wants to go. A switch uses its MAC address table to make forwarding decisions. So this is kind of like how a MAC address table would look like. We have the destination address and we have the ports. Let's say you want to go to the MAC address EE, then it has to go through port 1, EA port 4, and so on. Something to note is that a switch will never allow traffic to be forwarded out of the interface it received the traffic from, meaning that if a frame came in from port 1 and it wants to go out port 1, that will never happen. In this diagram, if a message enters switch port 1 with the destination address of EA, then the switch port forwards the traffic out of port 4. So it will look up its table. EA is at port 4, so this frame will be sent out of port 4. Layer 2 Ethernet switches forward frames based on the destination MAC address. A switch will use destination MAC address to determine the egress interface, the interface that is exiting. Before a switch can make this decision, it first must learn what interface the destination is located. It must know of all my interfaces, where does it lead to? So it will first have to learn that. A switch builds a MAC address table, also known as the Content Addressable Memory Table or CAM table, by recording the source MAC address into a table along with the port it was received from. The switch uses two-step process. One is learning. It doesn't know anything, but it has to learn, so it will examine the source addresses. Add the source MAC if it is not in the table, and then reset the timeout setting back to 5 minutes if the source is in the table. Now the purpose for this timeout setting so that if something changes or the connection that is in that particular interface is down or is not alive anymore, then you can actually update the MAC table. Step 2 is forwarding. So it will examine the destination address. If the destination MAC is in the MAC address table, it is forwarded out the specified port. If the destination MAC address is not in the table, it is flooded to all interfaces except the one it was received. Switch use software on application-specific integrated circuits or ASICs to make very quick decisions. A switch will use one or two methods to make forwarding decisions after it receives a frame. So the two methods are store and forward or cut through. In store and forward switching, it receives the entire frame, meaning that it will wait until it gets the entire frame before it switches to the destination. It will receive the entire frame and ensures the frame is valid, no errors. Store and forward switching is Cisco's preferred switching method. In cut-through switching, the switch forwards the frame immediately after determining the destination MAC address, and then it will send it to the egress port. So it doesn't actually wait for the whole frame and doesn't check errors. Store and forward receives the entire frame, computes the CRC, cyclic redundancy check, and if the CRC is valid, the switch looks up the destination address, which determines the outgoing interface, and then the frame is forwarded out the correct port. If there is an error, it will not be forwarded. Cut-through switching forwards the frame before it is entirely received. At a minimum, the destination address of the frame must be read before the frame can be forwarded. That is logical. If you want to forward, the very least you need to know is the destination where it is going to. Store and forward has two primary characteristics, error checking and automatic buffering. In error checking, when the switch receives the entire frame, it will compare its own calculation of frame check sequence to the value that is in here, which is the last field in the frame. If there are errors, then it will be discarded. If there are no errors, the frames will be forwarded. The ingress interface will buffer the frame while it checks the FCS. This also allows the switch to adjust to a potential difference in speeds between the ingress and the egress ports. In cut-through switching, we have rapid frame forwarding. The switch can make a forwarding decision as soon as it has looked up the destination address. It doesn't wait for everything else, just the destination address. Fragment-free method will check the destination and ensure the frame is at least 64 bytes. This will eliminate runs. Runs are frames that is less than 64 bytes and have very bad FCS. And usually runs are created when there is a collision. This provides better error checking than cut-through, with practically no increase in latency. Concept of cut-through switching is appropriate for switches needing latency to be under 10 microseconds. Does not check the FCS so it can propagate errors. That's not a good thing. You don't want errors to be propagated throughout the network. It may lead to bandwidth issues if the switch propagates too many errors, and it cannot support ports with different speeds going from ingress to egress. Switching domains. During the course of your lessons previously, you have heard something about collision domains, broadcast domains. So we are going to look at those two. Switches eliminate collision domains and reduce congestion. This PC is connected to one of the interfaces in the switch, and this connection is just between the PC and the switch. Nobody else, no other devices are in that. So there is no collision. When there is no collision, it reduces congestion. If you remember, when there is a collision, everybody backs off and then they will try and submit again. So in switches, when you eliminate the collision domain, you don't have congestion. When there is full duplex on the link, the collision domains are eliminated. When there is one or more devices in half duplex, there will now be a collision domain. There will now be contention for the bandwidth, meaning I want to use it or you want to use it, so there is contention. Contention, you can say like a competition, who gets to use the bandwidth. Collisions are now possible in half duplex. Most devices, including Cisco and Microsoft, uses auto-negotiation as the default setting for duplex in speed. Broadcast domains, if you remember, is the gossip central. Okay, a broadcast domain extends across all layer 1 or layer 2 devices on a LAN. Only a layer 3 device, a router, can break the broadcast domain, also called a MAC broadcast domain. For a switch, which is a layer 2 device, it is gossip central. Whatever it gets, it sends to everyone. When you attach a switch to another switch, now the gossip central has widened. The only way to cut broadcast domains are to use layer 3 devices like routers. The broadcast domain consists of all devices on the LAN that receive the broadcast traffic. So this is one broadcast domain. This is one broadcast domain. When the layer 2 switch receives the broadcast, it will flood it out all interface except the ingress interface. Too many broadcasts may cause congestion and poor network performance. Increasing devices at layer 1 or layer 2 will cause the broadcast domain to expand. So we will try, when you are creating or designing a network, to not make the broadcast domain so big with too many devices in it. Switches use the MAC address table and full duplex to eliminate collision and avoid congestion. Features of the switch that alleviate congestion are as follows. We have fast port speeds. Depending on the model, switches may have up to 100 gigabit per second port speeds. The faster the port speeds, the faster it handles the switching. Fast internal switching. This uses fast internal bus and shared memory to improve performance. Large frame buffers. This allows for temporary storage while processing large quantities of frames. High port density. This provides many ports for devices to be connected to LAN with less cost. This also provides for more local traffic with less congestion. So when you are going to buy a switch, for example, these are some of the things that you have to look into. That is the end of today's lesson. It's a very short lesson, and most of the things we have learned previously. So it is just like a reminder of what is going on. So until the next lesson, goodbye.